Hello and welcome to the University of Portsmouth BSc Marine Biology course talk for all those potential applicants out there. My name is Dr. Joanne Preston. There's a little photo of me in the top right corner. This obviously isn't the usual way that we do it, but hopefully I'll give you enough information that will help you make a decision about the best degree for you. So, the undergraduate degree pathways. Here at the University of Portsmouth we have three: BSc Biology, Marine Biology and Biochemistry. And we were the first marine biology degree in England to receive the Royal Society of Biology accreditation. And I've also previously and in the process of reaccrediting the IMAREST, the Institute of Marine Science, Engineering, Science and Technology. This is essential because we believe that our degree gives you the employability that you need to go forward in a career in marine biology. Now, here's a little bit of sales pitch really, but a reflection of how passionate we are about the teaching we deliver here at the University of Portsmouth. We have a prestigious gold rating in the Teaching Excellence Framework, which is basically a way of rating the standard of teaching at universities, and we are the only one of 4 gold rated universities in the southeast, something that we are enormously proud of. Now, any marine biologist worth her salt will be aware of Jacques Cousteau, who said the sea, the great unifier, is man's only hope. Now as never before, the old phrase has a literal meaning. We are all in the same boat. There is a link to a video here which I will leave you to do in your own time. But needless to say, if you come to Portsmouth, it is your degree, but we have an aim, which is for you to become a confident, skilled, excellent marine biologist. And I just want to draw your attention to the little bit of land that comes out into Langstone Harbour. This is at the very eastern side of the Portsmouth Island, and the Institute of Marine Sciences is here, right in the mouth of Langstone Harbour. So we have access to fantastic marine ecosystems all around us. Our degree is unashamedly applied, as well as containing the academic and research excellence you expect from any marine biology degree. That's because we want to equip you with real world knowledge and skills, which enables you to play an active role in transforming the way that we utilise and conserve and protect the marine environment, but fundamentally gives you great opportunities for employment both in the UK and globally. So what does the marine biology degree look like here at the University of Portsmouth? So we believe that in line with our Royal Society of Biology accreditation, that over-specialisation early on is not advised, and marine biology is a biological discipline, and we passionately believe that you need a good, strong core grounding across the biological sciences. Therefore, our first year has all core units and ranges from introduction to marine ecology and oceanography to experimental marine biology, but also molecular and microbiology, cell biology and biochemistry, biodiversity and evolution, and then a whole package of what we call graduate skills. And this is where your tutorial will sit, but also the softer and other skills that go alongside your degree training. Then in year 2 and year 3 it is entirely specialised into marine biology, although you have a whole range of optional units you can do. In your second year you have 4 core units, as you do in your third year, and in the second year you have an additional 2 optional units from the several that are listed there, and in year 3 you have 1 optional unit that goes alongside your third year project, which is a large part of your training to become an independent scientist. So just to drill down into the marine biology first year, this is some of the elements of the different core units you'll be doing. So of course, biodiversity and evolution, you understand how life evolved on our planet, and we introduce you to the major marine phyla as well as the all phyla. Introduction to Marine Ecology and Oceanography does largely what it says. Marine Ecology and Ocean Processes. Cell Biology and Biochemistry, you're looking at metabolism, enzymes and proteins. Marine Experimental Biology has a whole range of experimental skills, from dogfish dissection, understanding the relation of structure to function in vertebrates, marine vertebrates, DNA extractions, screening oysters for diseases, statistics and other experimental skills such as microscopy and titration. Molecular biology and microbiology is a foundational part of our degree, as you can go on to specialise in both of these things as you go across your marine biology degree. So microbiological techniques, DNA processes and cellular processes. And then the graduate skills, beyond the tutorials, we give you background chemistry and maths and statistics to get everyone up to speed in the place we want you to be. The second year, it gets much more marine-y from this point onwards. Marine organisms and ecosystems is a fantastic unit which goes through all the different marine habitats and looks at how environment shapes the community of species that are found there and how these species are adapted and tolerant to their environmental conditions. And we look at things from Antarctica, where we have Professor Lloyd Peck coming to give a guest lecture from his research with British Antarctic Survey, to habitat mapping silt marshes, to benthic ecosystems, to mangroves and tropical coral reefs and seed grasses. Animal science, this is where you learn how the physiology, comparative animal physiology, behaviour and ethics of marine science. And then marine research skills, which builds on your first year skills units, and this really takes you into more specialist marine related skills for both research and employability. So GIS, taxonomy, boat skills, offshore sampling, marine molecular biology, to name just a few. And the community ecology and residential field course unit is where your field trip sits, and that is a core residential field trip either in the UK or abroad, normally in Mexico, alongside community ecology training into ecological networks, experimental design, field sampling and taxonomy. The second year optional units: oceanography, biological, physical and chemical ocean processes and offshore sampling. Microbiology looks at microbiological interactions as well as all the practical applications of that subject. Genetics, which looks at molecular biology theory and applications, including next generational sequencing. We have teaching for biosciences for those who are thinking going on in a career of teaching. Plant science, that covers plant physiology, algae and climate change. And also the basic and scientific diving and the practical boating skills, which are very popular units which can take you through either PADI, open or advanced, alongside the scientific and technical diving qualifications. And the practical boating skills is a fantastic, which takes you up to power boating level 2 with your radio courses, and is delivered by Portsmouth Marine Training, which is just around the corner from the Institute of Marine Sciences, and a fantastic company and provider of that. Your third year, obviously your honours project. You'll choose this in the second year. We'll offer you a whole range of projects, from being supervised by the academic staff, who I'll introduce you to at the end of this talk. And you'll be interviewed and assigned a project where you'll start in either the summer between year 2 and 3 or in September in year 3. And this goes through the whole of your year 3 and is a really large part of your third year and a large part of your degree. And this is your chance to really delve into research in an area of academic research which really excites and motivates you. Alongside that, you'll do marine ecophysiology, marine ecology and conservation, and fisheries and aquaculture. And these are really starting to form your expertise and get you ready for further research, further study, or going to work in marine biology related positions and jobs. In your third year, you can choose one of 2 optional units: global climate change for marine systems. Never has that module been more relevant, where you look at climate models, ocean acidification, extreme temperatures and the combined impacts of all these things. or environmental microbiology. Covers such things as biogeochemical cycling, extremophiles and deep sea systems. Field courses. Marine biology is an academic subject, but it's also very much an applied and field-based subject. And we need you to get out into the field and experience and learn the different survey techniques that you need to do going forward in your research or future work, and also to start building up your expertise, your species identification knowledge, your understanding of how ecosystems work and how we survey and sample them. So in the first year you have several locally based one-day field trips, such as to Lulworth Cove, look at Rocky Shore biology there. The second year you have your 7 to 10 day residential field course, either UK or tropical, and in all years there's field trips associated with several units, including trips to aquaculture facilities, boat trips referring to coastal management, looking at different habitats, and of course in your third year project it may well be a highly field-based project. It may not, it may be data-based, it may be lab-based, but there's a large likelihood that you will have a field-based third year project. So slapped and lay. This is our UK temperate field course, which you'll go to in the second year if you're not going to Mexico, and here you'll be getting out in the field and looking at rocky shore ecology, soft sediment ecology and estuarine ecology. It's a fantastic location in Dorset, and it is very popular, and you learn the same skills that you would do in Mexico, which is our tropical ecology field trip, where you look at mangrove ecology, coral reef ecology and seagrasses. Although the ecosystems are different, the survey techniques and the knowledge that you acquire is the same. The Slapton trip is at no additional cost, and the Mexico field trip is at an additional cost of around between £1,000 and £1,500. So let's have a look at some of the honours research projects. This is a major piece of largely independent study where, with guidance from our supervisor, you conduct your own novel research. And here are two of my previous students setting up the very early part of our Solent oyster restoration project, when we started to develop a novel aquaculture restoration system for inputting larvae back into the Solent. And this goes on to why you might want to come to Portsmouth and the University of Portsmouth and to do marine biology, because of our facilities. We have fantastic teaching laboratories both at the Institute of Marine Sciences and up at the main site in the centre of town. This includes all our teaching and seminar rooms. At the Institute of Marine Sciences we have 4 research laboratories. We have a £2 million aquatic centre with flexible research systems, so we can design and build experiments as we need to, and research labs with temperature control rooms, a marine resource centre and 2 research vessels, and the one in the picture there is the RV Noctiluca. We also have a research platform in the middle of Langston Harbour where we can deploy samples and measuring sondes or probes, and it's used for many undergraduate projects as well as deploying equipment and testing materials. And of course, as a marine biologist at the University of Portsmouth, you have all the access to our fantastic resources at the main campus. Now, we are one of the top 25 universities in the UK from the Guardian University Guide 2019. 97% of graduates are working or in further study. It's number 1 in the UK for boosting graduate salaries, and Robert Halfon, from the chair of the House of Commons Select Committee, really highlighted the prestige that should be put on universities such as Portsmouth that boost students' career prospects and earnings, citing them as powerful engines for social mobility and put rocket boosters on the life chances of those who may otherwise have stagnated and deserve to take plaudits. So again, why Portsmouth? Here we are. Again, I'll just highlight to you where we are on this map here. This is the Institute of Marine Sciences, and we pretty much are in the sea. But why is the Solent a good place to do marine biology? Well, we're in the middle of the fantastic area of Solent European Marine Sites, or SEMS, and this is a whole variety of Ramsar and special areas of conservation, sites of special scientific interest, and so we have lots of protection because of all the fantastic marine habitats we have here: kelp forests, seagrasses, salt marshes, oyster reefs, as well as understand the challenges of how do we protect, manage and conserve and study the marine realm, marine ecosystems, whilst managing coastal cities and pollution and human uses of it, be it fishing, maybe it navigation, maybe it ferries, but transport. All these things come to the heart of what it means to be a marine biologist, understanding these interactions of humans in the marine environment, as well as just purely interactions within the marine environment. We also have research excellence, and there is a strong emphasis on international applied marine research at the University of Portsmouth, and with our last research excellence framework from 2014, the next one's coming up. It's been postponed because of coronavirus, but 100% of our research was categorised as having outstanding impact, and 72% were world leading or internationally excellent. Our ranking was greater than Aberdeen, Plymouth and Stirling, and equivalent to Bangor and Aberystwyth. So our teaching is research led and our research is excellent. Here are some examples of what we do at the University of Portsmouth: ecotoxicology, marine ecotoxicology, the impact of pollutants through the food chain into the marine environment, and we really study at the environmentally relevant concentrations of pollutants, from heavy metals to Prozac and other antidepressants, even the presence of drugs in water such as cocaine. We analyse the effects of these on marine organisms, and there's a prawns and Prozac headline from The Sun a few years ago, and some seals basking in the middle of Langston Harbour, just a matter of 100 metres or so away from the Institute of Marine Sciences, where we've been tracking their behaviour and looking at pollutants and contaminants accumulating in whiskers. We also have research into aquaculture and making it more sustainable, sustainability in marine trade. We have research that goes into developing renewable energies, particularly using the enzymes from wood-eating marine organisms such as the gribble, which you can see up here in the top corner here. And here below we have some fluorescence microscopy highlighting a novel enzyme, cellulase enzyme. And this will hopefully go towards increasing what is currently the rate limiting step of producing. We have experts in tropical ecology such as Dr. Ian Hendy and a lot of work, and Professor Simon Cragg, who've been doing a lot of work in the mangroves and looking at blue carbon and carbon capture and the role they play in supporting not only the drawdown of carbon dioxide but global fisheries. We have marine ecologists that find out new ways of predation, such as this nudibranch, who was discovered to be a kleptopredator. And then we have a lot of fisheries work and collaborate with CFAS and the Shark Trust. This was an accidental trawl of a large number of catfish, and both CFAS and all our students took over the Institute of Marine Sciences to make the most of this unfortunate trawl through a breeding ground, and so therefore spend weeks defrosting these cubes of sharks and getting as much data as possible as we could do to prevent this happening again. We have acoustics specialists such as Dr. Sarah Marley that traces cetacean movement around the globe, and they paired up with this Round the World Yacht Challenge to see if they could put a hydrophone to the bottom of the boat and use it as a way of tracking cetacean migration in a way that had never been done before. Obviously, a sailing boat doesn't have any engine noise and doesn't frighten them away. We've got research into climate change, both through calcareous carbonate reefs, and the combined effects of climate change on all organisms that are in the marine ecosystems. We've got research into plastic pollution, from macroplastic to microplastic, And the university itself is leading the way in removing all plastic it can, single-use plastic, from all of its cafes. This is some research that came out of Portsmouth looking at how most of the microplastic was actually fibres that came through the route of washing machines. And of course we had this world-hitting headline from Professor John McGinn, in our Professor of Structural Biology here, who identified and characterised a novel plastic-eating enzyme. We are leading the field in marine conservation, restoration and policy, such as the Solent Native Oyster Restoration Project, which aims to put 5 million oysters back into the Solent and fundamentally restore a forgotten ecosystem. That's me standing in front of a tank of oysters when I was presented on the Today programme, and explaining that these humble creatures can filter almost 200 litres of water a day. That's our students with Ben Fogel and one of the cage systems we developed to hang under marinas to act as broodstocks to help with conservation of this species. So our research topics are wide and varied, and we work with a whole range of partners. And if you come to our university to do your final degree projects, you can do research alongside us. Our graduates are successful. They go on to do some really exciting and novel things, as well as what you'd expect, to work in government organisation, conservation organisations, go on to do further research and be scientists and lecturers themselves, be teachers, be environmental consultants. Some set up their own companies, such as the Chatty Scientist and Flugelbinder. The Chatty Scientist shares the wonders of science through science communication. Flugelbinder does sustainable ecotourism. We have people that go into underwater photography and filming. We have graduates like Kira Coley, who became a senior editor of the Eco magazine. We have students that are going on to do really vital conservation work, such as in seagrasses in Australia. And Professor Lloyd Peck is actually an alumni of our university as well, and has been doing cutting edge science about in Antarctica. So you can use your marine biology to go onto a whole range of different careers, from conservation and restoration, marine resource management or coastal zone management, fisheries. We need good fisheries scientists. We need well-informed marine policy and governmental agency workers. You can become a researcher or a technician, work in science teaching from school up to being an academic at the university, marine science communication, or use your diving skills for underwater filming or subtidal marine research. The world is your oyster. Here we are. This is the Marine Biology Academic and Teaching Staff, University of Portsmouth. And we are here to help you reach your potential. The last NSS, the students report the staff are good at explaining in pretty much 98% of the time. We are passionate about our science, we're passionate about our research, and we're passionate about our teaching. If you want to get in contact, here are the details, and thank you for listening. I wish you all the luck with your decision in this really important part of your education, training and career. Goodbye.